And welcome back to Matt's Workshop. Today I have a shop improvement project. Actually, a shop accessory project for you. I will soon need to relocate my entire shop, including moving all the machinery out. Some of these machines, like the Bridgeport, are very heavy. Now, I've moved all these machines in the past in and around my shop using various methods, such as rolling them on pipes, using an engine hoist, but by far the easiest method was when I borrowed a set of machinery rollers, or machinery skates. It makes moving a breeze. You just jack up the machine on cribbing with crowbars, slip the skate underneath, pull the cribbing blocks out, and drop the machine down onto the skate. You can then just push the load around the shop with ease. The only problem? Machinery skates can be very, very expensive. Like hundreds of dollars each, and you need 3 or 4 in most cases. So let's build our own. On the welding bench here, I have some of the materials for today's project. This rusty material is standard 4-inch mild steel C-channel cut-off leftovers from previous projects. And you can see a stack of ball bearings I purchased from eBay. They are available at very little cost when you order in quantities of 10 or greater. Here's a closer look at the bearings. These are called 6204 double shielded. They're about 47 millimeters, roughly 1 3/4 inch outside diameter, with an inner bore of 20 millimeters, maybe around 3/4 of an inch, and 14 millimeters, or roughly a 1/2 inch wide. Don't quote me on the metric conversions, I work in inches. The steel channel will become the base or shoe of the machinery skates. This material is 1-inch hot-rolled steel bar stock to be used as the axles. Using the power hacksaw, I cut the C-channel and the round bar into rough lengths, then I lightly deburred the cut edges using a flap wheel on the angle grinder. I went over to the local Harbor Freight and bought a box of retaining E-clips. This is what they look like. And here's the C-channel after being prepped. I tried to clean up the mill scale and rust from the bottom with the grinder because I want to weld the axles in place on this surface. I then also chamfered the corners and smoothed the edges slightly. My plan is to weld the axles like this onto the channel. The axles need to be spaced evenly, perpendicular to the channel, and parallel to each other. I will turn down the end of the axles to be a slip fit into the bearing bore, leaving an inside shoulder for the bearing hub to seat against. And I'll need to cut a groove near the ends of the axles for the retaining E-clips. So, without further ado, let's get started. Over on the lathe, I mounted the 5C collet chuck to hold the work. Keep in mind that the bar stock is 1-inch diameter nominally, and as being hot rolled, there's mill scale and an oversize allowance, so I'm forced to use a 1 1/32 collet. Luckily, I have a full setup of 5C collets in 1/32 of an inch steps. The first operation will be to clean up the saw marks on each end with a quick facing cut. Since I'm making 4 skates with 2 axles each, I need to work on each end of the axles. That's going to be 16 facing operations. And it goes like this. I insert the bar, tighten the collet, move the carriage over, face the end with the cross slide, move the carriage away, open the collet, flip the part end for end, tighten the collet, move the carriage back into position, face this end, move the carriage away, open the collet, and repeat 7 more times. Opening and closing the collets is very time consuming since I don't have a lever action collet closer on this machine. Additionally, hot rolled steel is not very round, so I need to open the collet a long ways to get the material in and out, and when I'm inserting the material, I don't want it to bottom out against the lathe spindle, because drawing the collet back would bind it up in the chuck. So I push the bar all the way in until it touches the spindle nose, and I pull it out maybe a 1/4 inch or so. Then I can fully tighten the collet and proceed. And the next operation is to center drill the end of the bar for a ball bearing live center. Again, I need to perform this for every piece. Now that they're all center drilled, I'm using a ball bearing live center to increase rigidity since I have so much sticking out from the collet. As I mentioned while facing the ends, the bar is not pushed up all the way against the spindle nose so as not to bind up the chuck. That leaves me with somewhat random length of stick out, and I want to turn a shoulder to a specific length, and I want them all to be the same. An easy solution is to set up a carriage stop on the lathe bed. To set the carriage travel before contacting the stop, I made up a stack of gauge blocks. The idea is to move the carriage and cutting tool up against the faced end of the work. Then, holding the gauge block stack against the carriage apron, I'll adjust the micrometer stop until it touches the gauge block. Now I can run the carriage all the way to the stop, and I'll end up with the correct shoulder length. If I reset the carriage stop for each bar, they should all end up at the same length. So I'll continue to make passes, taking off about 30 thousandths each time until I approach the target diameter. Measuring with a digital micrometer, I can sneak up on the final dimension. I'm also checking in a few locations to determine if I have any unwanted taper. And here I am test fitting the bearing. Remember, we're not going for any sort of press fit. I just want the bearing to slide over the axle and seat all the way up against the shoulder. Now obviously, we don't want any sloppy fit, and this feels right as it is. And a quick chamfering with a lathe file to break the sharp edges. Now I can remove this piece and move on to the next. Here is the same turning operation from another angle. As I approach the final diameter, I can back the carriage very slowly, dragging the tool as a spring pass or a cleanup pass to remove any tool marks or minor chatter. And if necessary, I can use the lathe file to take off a thou or two. I really like these USA-made Simmons lathe files. They cut very cleanly and don't get buildup stuck in their teeth. Now over at the milling machine, I want to mill a flat along the large diameter of the axle so it will sit flat against the C-channel when it comes time to weld. So I have a stack of parallels in the vise to hold the axle at a good height, and I have a 6-insert face mill mounted in the machine. This mild steel seems to cut really well, so I'm running the spindle at about 1,000 RPM. The flat that I'm cutting is about 1/8 of an inch deep. Okay, here are the axles with the flat milled and a mock-up with the bearing rollers installed. The shoulder just overhangs the C-channel by about 1/8 of an inch. Now, this prevents the bearing outer race from rubbing up against the channel when I'm using this. And I might add a washer between the bearings, so I'll take that extra width into account when it comes time to mill the slot for the E-clips. And the skate has a nice low height of less than about 2 inches. I think they'll work well for me. In the middle of the channel, I want the ability to add a block of wood if I need more height. That's why I have the C-channel facing up. Back to the axles on the lathe. Here, I just finished cutting the groove for the E-clip. Now I'll do some quick layout for a few holes in the C-channel. I need to locate the axles about 1 inch from the ends. Then the screw holes for the wood block will be another inch inside that and 1 inch from the sides. I drilled these 4 1/4-inch holes on the drill press. And here I'm using a countersink bit to chamfer the sharp edges inside and out. I also want a 1/2 inch hole at either end of the skate. This required using a clamp to hold the work flat to the table. Now this is an old Kennedy Auto bench mount drill press from about the 1930s. I have updated it with a variable speed permanent magnet DC motor sourced from an industrial conveyor belt system. And the speed controller is just a standard MC60 controller used with like a running treadmill. Again, I'm using the countersink bit to add a quick deburring chamfer to these holes. I just finished up welding the axles to the C-channel, and I've masked the ends of the axles in preparation for painting. And here's the equipment I'll use to paint. This is just a Harbor Freight powder coating kit I've had for about 10 years. I've decided to mix my own custom color powder from a 50-50 mix of yellow and red to create kind of a safety orange color. It sure resembles the orange dust left on your fingers if you were to eat Cheetos. Now this is the first time that I've intentionally mixed two paint powders, and I'm pleasantly surprised at how uniform the color has turned out. I'll bake the parts in this little toaster oven, and I'll use the wire rack to suspend the work. With the power supply turned on and compressed air connected, I'll just shoot a very liberal amount of powder over the work. The ground wire is attached directly to the work to complete the static electricity attraction. You gotta be sure to shoot the powder from all directions if you want good coverage. You can just see some thin wires holding the axles to the wire rack. When I turn the rack upside down to apply paint to the bottom, the skate hangs down about 1/4 inch from the rack. This is how it'll also go into the toaster oven. And I have the oven set to about 425 degrees Fahrenheit, and I'll set the timer to max, which is about 15 minutes. Here we are after 15 minutes, and the powder has just started to melt and flow out. I'll continue to bake the part for an additional 15 or 20 minutes. Okay, the powder is done, and I can remove the skate from the oven to cool down. Now that the paint has cured, the hardest part is removing the blue masking tape. The oven heat has made the glue very sticky, so I need to use some solvent to clean up the axles. Now it's time to mount the bearings and install the retaining clips. Here's the wood I plan on using. This is a rough sawn 2x3 Doug fir. It sits nicely within the C-channel and sits a little higher than the flanges. Again, I will have 4 screws holding the wood in place from the bottom. Okay, with the 4 sets of machinery skates made, that'll do it for this video from Matt's workshop. I hope you found something helpful, and thank you for watching, subscribing, and commenting.